I'm Beth Koigi, 28 years old, the CEO of Majik Water, a project manager by profession. So Majik Water is a Kenyan company that was started in 2017 while I was doing a program at NASA Research Center in California, where they brought around people from all over the world to just interact and talk about global issues and how to use technology to solve them. I was looking at how can you democratize a water source, so you don't have to depend on tap water or any other water source for you to get basic drinking water, and especially where there is a lot of water issues, that is arid and semi-arid regions. I previously worked in water filtration, so we were making and distributing water filters, that is low-cost, low-tech water filters, and I did that for 5 years. Kenya had a lot of water issues in terms of water scarcity in 2016, and the sales were really bad, so people were not investing in water filtration. And for me, I started now seeing and looking at this issue more of a water scarcity. We are getting water from the atmosphere. This is making use of the water vapor in air. And there are very many ways you can get water from air. You can get dew or harvest dew. You can harvest fog and mist. And you can harvest now the humidity itself. When you're harvesting humidity, you can use also two types of methods. That is the condensation, and the other one is using special kind of materials that have very high affinity for water molecules. So basically they absorb water vapor in air, and when you heat them up, they release that water. So at the moment, with this machine, we are using the condensation model. You can harvest as much water as possible. What depends is the capacity of the device. Like for example, this device behind me, it's 500 liters per day, but you can harvest, we have devices that can harvest 1,000, and you can custom make them to harvest 100,000. An example of these 500 liters, this is 1.5 million. So the cost is a bit higher at the moment, but the cost will go down as the technology advances. We have only distributed eight of these big devices. Our actual target clients and our actual clients are very different. Initially, we targeted people living in arid or semi-arid regions or anywhere there is water issues. And then we found out that most people do not have the capability to pay, even if they buy per liter. Right now, we are working with NGOs who are also working in such regions, so who have water projects. We also work with corporates who are doing part of their CSR or who want to reduce over-dependence on the grid water source. You can use electricity. At the moment we are doing testing here, we are using electricity that is on the grid, but you can use solar energy. You can also use any form of energy. You can use a generator, so depending on what you have. So basically this is a very, I would say it have like 4 components which are identical. So this part is very identical to this part, it's very identical to this part, and it's very identical to this part. So you will see they look pretty much similar, but in each part we have the condensation coil. So basically this is where the condensation takes place. We have the fan. So from here you'll see an air inlet where this fan pulls in air, which goes through the condenser coil first, and then the hot air is expelled. So we use the similar compressor refrigerant kind of system, very similar to a fridge. So we have the compressor, and then we have the refrigerant gas. The refrigerant gas is mostly used for the condensation heat. So basically we just condense. It's a different kind of air conditioner or a fridge. So basically the water, when it's condensed here, it falls on this tray. Then on the other side you'll see a pipe connecting all the 4 parts together. So it goes through an outlet we have on the other side, and then the water comes to an external tank. The pollution doesn't affect the quality of water we get. simply because we just condense the water vapor. So probably the water doesn't come in contact with the chemicals in air. So basically we just condense water vapor, so the pollutants may come, or the contamination may come from the device itself. The machine can be dusty because we are pulling in air, so there is a lot of dust in air. So most of the dust will come into the machine. It may or may not interact with our water, but there is a huge possibility. But at the end of the whole system, we add filtration system just to make sure that the water is safe for drinking, and especially if it is being used for drinking. And also we add mineralization chamber, because basically we just get H2O, which is, you know, distilled water. So we add mineralization just to make it now more better for drinking. Like any new technology, getting into the market is not new, convincing people. The first thing we want to do is reduce the overall cost of these devices in such a way that anyone can afford them easily, and also make them, you know, people become more aware that this is actually a water source that people can, you know, consider.